Question 1. f of x is x cubed plus 2x squared minus 8x plus 5. We need to find the second derivative of our function. So differentiate it once and differentiate it again. So our first derivative, we're going to times by the power, take one off the power. So it's 3x squared plus 4x minus 8. And then our second derivative, we're differentiating again. Times by the power, take one off the power. 6x plus 4. Part B, solve. Our second derivative is equal to 0. Find where our second derivative is equal to 0. And they will be, that will be the point of inflection. So 6x plus 4 equals 0. Take away 4 from both sides. Divide by 6. So negative 4 over 6 or negative 2/3. Hence, find the range of values for which of x, for which f of x is concave. So concave is when it's shaped like a cave. So in this shape like this, curving downwards. And it is where our second derivative is negative, less than 0. So the gradient is going down, the gradient is decreasing. It's starting as positive here, it's getting lower and lower and lower and lower. So we want to know where 6x plus 4 is less than 0. We don't actually need to solve this again. Take away 4, divide by 6. So x has to be less than minus 2/3. A sequence u1, u2, u3 is defined by u1 is 35 and un plus 1 is equal to un plus 7 cos n pi over 2 minus 5 times negative 1 to the power of n. Show that u2 equals 40. So when we want u2 equals, so u2 equals u1, so n is 1 in this case, plus 7 cos n is 1, so pi over 2, minus 5 times negative 1 to the power of 1. And u1 is 35. So we can just type this into the calculator. 35 plus 7 cos pi over 2 minus 5 times negative 1, which is 40. Find the value of u3 and the value of u4. So again, u3 is going to be u2, which is 40, plus 7 cos, now n is 2, so it's going to be 2 pi over 2, minus 5 times negative 1 squared. So we get 28. And u4. So the 2 is going to become 3s. And the previous one was 28. 33. Given that the sequence is periodic with order 4, so it goes 35, 40, 28, 33 over and over again. So it went 35, 40, 28, 33, then it will repeat over and over again. So U5 will be 35. Find the value of, so the first 25 terms. So the first 25 terms, so starting with 1 all the way up to 25, the sum of the first 25 terms. So we can do, so the first 24 terms, it repeats, the first 4 repeat over and over again. So if we add up the first 4, so the first 4, 35, 40, 28, and 33, is 136. So that's going to repeat for the next 4, and the next 4, and the next 4. So we'll have 6 lots of that, and then back to the first one again. So we're going to have 6 lots of 136 plus another 35. So that'll be the first 24 terms. The 25th one will be 35. So we get 851. Question 3. Given that log 2x plus 3 plus log 2x plus 10 is equal to 2 plus 2 log 2x, show that 3x squared minus 13x minus 30 equals 0. So we're just going to use the rules of logs to do some rearranging here. So when we have a plus with the logs, we can times the 2 arguments. We can join these 2 logs together. So we can change it into log base 2, x plus 3 times x plus 10. And then that's equal to 2 plus 2 log 2x. When we've got a 2 in front, we can jump it up and have it as a power of the argument of the x here. So log 2x squared. I'm going to take this log 2x squared away from both sides. And I'm also going to expand these brackets. So I'll have log base 2 x squared plus 10x plus 3x plus 13x plus 30 minus log 2 x squared equals 2. When we have a minus between 2 logs, we can change it into a divide. So I can have log base 2 x squared plus 13x plus 30 over x squared equals 2. Now I can take this out of log form. So 2 is the base. It's got 2 as a power, so 2 squared equals this. So 2 squared is 4. So I can write 4 equals, or x squared plus 13x plus 30 over x squared equals 4. So I can now times both sides by the x squared. X squared plus 13x plus 30 equals 4x squared. And then move everything over to the right hand side. Make it equal to 0. So I've got 3x squareds minus 13x's minus 30. Hence state which of the roots in part BI is not a solution of. Okay, write down the roots. So we need to write down the roots first, and hence state which is not a solution. So let's find the roots. So let's just use the calculator and solve. So we've got 3x squared minus 13x is minus 30. So we've got 6 and minus 5 over 3. So which is not a solution? So if I try to type into the calculator log 2, a log base 2, minus 5 thirds, minus 5 thirds, that gets an error. So the right side of the equation is 2 plus 2 log 2 5 thirds, which doesn't work. It's an error because 2 to the power of something can't be a negative. So which of the roots is not a solution? Minus 5 thirds, because 2 to the power of something cannot equal minus 5 thirds. Coffee is poured into a cup. The temperature of the coffee, H degrees Celsius, T minutes after being poured into the cup, is modelled by the equation H equals AE to the power of minus BT plus 30, where A and B are constants. Initially, the temperature of the coffee was 85 degrees Celsius. State the value of A. So initially, T is 0. And so E to the power of minus BT is going to be 1. E to the power of 0 is 1. So H equals A plus 30. So 85 equals A plus 30. A must be 55. Initially, the coffee was cooling at a rate of 7.5 degrees Celsius per minute. So the rate of change is the gradient function, dH dt, the change in temperature with respect to time. So that's when T equals 0. Initially, when T equals 0, dH dt is cooling, so it's minus 7.5. Find the complete equation linking H and T, giving the value of B to 3 decimal places. So let's find dH dt. When we differentiate E, it stays the same, but we times by the power differentiated, which in this case is minus B. So, and it's H equals 55E minus BT plus 30. So times by minus B, so minus 55 B E to the power of minus BT. The 30 disappears, so that's our gradient function. And we know that when T equals 0, dH dt is equal to negative 7.5. So negative 55 BE to the power of minus BT equals minus 7.5. But T equals 0. So we just get minus 55B equals minus 7.5. Because T is 0, E to the power of 0 is 1. So we've just got minus 7.5 over minus 55. So minus 7.5 over minus 55 is 3 over 22, or 0.136. So B is 0.136. So find the complete equation linking H and T. So H equals 55. E to the power of minus BT plus 30. Question 5. The curve C has equation y equals f of x. The curve passes through the point P at 3, -10. Has a turning point at P. So the gradient is 0. dy dx equals 0. Given that dy dx is this, where k is a constant, show that k equals 12. So we know dy dx equals 0 at when x is 3. So when x equals 3, dy dx is 0. So we should just be able to substitute in 3 and make it equal to 0 and find k. So 2 times 3 cubed plus 9 times 3 squared plus 5 3's plus k equals 0. And 2 times 3 cubed minus 9 times 3 squared plus 5 3's is -12. So -12 plus k equals 0. So k equals 12. Hence find the coordinates of the point where C crosses the y-axis. So to find out where it crosses the y-axis, we're going to have to integrate to find the function to make it y equals. So if we integrate, add 1 to the power, divide by the new power. So 3 plus 1 is 4. 2 over 4 is the same as a half. 2 plus 1 is 3. 9 over 3 is 3. Add 1 to 1, we get 2. So we've got 5 over 2 x squared. We've got k is 12. So 12x plus c. So that's our function. We know it goes through 3, -10. So we can use that to find c. So we're substituting 3 and -10. And we will find out what c is. So half times 3 to the power of 4 minus 3 times 3 cubed plus 5 over 2 times 3 squared plus 12 3's, 18. So -10 equals 18 plus c. C is -28. So now we've got our complete function, which is y equals half x to the power of 4 minus 3x cubed plus 5 over 2 x squared plus 12x minus 28. It crosses y when x equals 0. Crosses y when x equals 0. Therefore, y equals -28. When x is 0, all of this bit here will be equal to 0, and it will leave us with -28. Relative to a fixed origin O, A is the point with position vector 12i, B is the point with position vector 16j, C is the point with position vector 50i plus 136j, and D is the point with position vector 22i plus 24j. Show that AD is parallel to BC. So let's go from A to D, which is D take away A. So it's 22, 24, take away 12, 0, which is 10, 24, or 10i plus 24j. B to C. So C take away B, 50i 136j. Take away B, which is 16, J, so 0, 16, which will be 50, 120, or 50i plus 120j. So we can see that B to C is 5 times 5 lots of A to D. So B to C equals 5 lots of A to D, therefore they are parallel. They're in the same direction. Same direction, just that one's 5 times as far. Points A, B, C and D are used to model the vertices of a running track in the shape of a quadrilateral. Runners complete one lap by running along all 4 sides of the track. The lengths of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, calculate the average speed of this runner in kilometers per hour. So we need to work out the distance. So it goes A, B, C, D. So we need to work out the lengths of all the sides. So we've got A to D, B to C, like so. A to D and B to C, they were parallel sides. So we've also got the length A to B and C to D. So A to B is B take away A, which is 0, 16, take away 12, 0, which would be minus 12, 16, and C to D, D take away C, which is 22, 24, take away 50, 136, so that's negative 28, negative 112. So let's just work out these distances now. So to work out the distances, we use Pythagoras. So we've got for A to D, the square root of 10 squared plus 24 squared, which is 26. For B to C, we'll have the square root of 50 squared plus 120 squared, which actually is going to be 5 times 26. But I'll do it again. 50 squared plus 120 squared, 130. A to B, we've got 12 and 16. 12 squared plus 16 squared, which is 20. And C to D, 28 and 112. 28 squared plus 112 squared. 28 root 17. 28 root 17 meters. So let's work out the total distance. So add on 130 and 20 and 26, 291.4. So total distance is them all added up. .291.4. But we're going round the track twice. So double it. So 582.9. And we want speed. So it's distance divided by time. So 291.4s divided by time, which was 5 minutes. But we want kilometers per hour, so let's back out of this. So our total distance, let's write, so 2 times 291.4 is 582.9. Let's divide it by 1,000, change it to kilometers. So 0.5829 0.5289 kilometers. And we've got 5 minutes. I'm going to store that as A. 5/60ths of an hour is 1/12 of an hour. 1/12 of an hour. So our speed is going to be distance divided by time. So alpha A divided by answer. So that's 6.99 kilometers per hour. A curve has equation x cubed plus 2xy plus 3y squared equals 47. Find dy dx in terms of x and y. So we're going to differentiate. So times by the power, take 1 off the power. We've got 3x squared. We'll use the product rule for 2xy. So 2x differentiated is 2. Y differentiated is dy dx. So we've got 2y plus 2x dy dx. 3y squared, again times by the power, take 1 off the power, but times by the bracket differentiated, which is dy dx, equals 47 differentiated is 0. So we don't want to leave it like that. We want to make it dy dx equals. So let's move all the terms without dy dx over to one side. So I have 2x dy dx plus 6y dy dx is equal to negative 3x squared minus 2y. Then we'll factorize out the dy dx. So it's dy dx times 2x plus 6y. And divide both sides by 2x plus 6y and get dy dx by itself. So we've got minus 3x squared minus 2y over 2x plus 6y. We could take the minus outside, but it'll be okay as it is. So I'll leave it like that. The point P, negative 2,5, lies on the curve. Find the equation of the normal to the curve at P, given your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So let's find the gradient. So at -2, 5, what's dy dx equal to? So it's -3 times -2 squared minus 2 5s over 2 -2s plus 6 5s. So that is going to be our gradient at that point. So -3 times -2 squared minus 2 5s over 2 -2s plus 6 5s. So minus 11/13. We want the equation of the normal. So we don't want a tangent. We don't want the same gradient. So the normal is perpendicular. So we need to flip a minus, do the negative reciprocal of that gradient, which would be 13/11. And we know it goes through -2, 5. So it's y minus y1 equals m times x minus x1. So we're going to have x1, y1, and m. So y minus 5 equals 13/11 times x minus -2, so plus 2, times both sides by 11. So 11y minus 55 equals 13 times x plus 2. 11y minus 55 equals 13x plus 26. Let's make it equal to 0 now. So I have 13x minus 11y, and I've got 26 and 55, which makes 81. Question 8. Express 2 cos theta plus 8 sine theta in the form r cos theta minus alpha, where r and alpha are constants. R is bigger than 0, and alpha is between 0 and pi over 2. Give the exact value of r and find the value of alpha in radians to 3 decimal places. So we're using our cos a minus b. So it's cos a minus b. This is in the formula book, is equal to cos a cos b plus sine a sine b. We're going to change a into theta, b into alpha. Cos theta minus alpha is cos theta cos alpha plus sine theta sine alpha, and I'm going to multiply each term by r. So now I've got r cos theta minus alpha, which is the form we're going to put it in, is equal to r cos theta cos alpha plus r sine theta sine alpha. And I can compare 2 cos theta plus 8 sine theta to this. So I can see that r cos alpha must be equal to 2, and r sine alpha must be equal to 8. So I can find alpha by doing my sine over cos, which makes a tan. So I'm dividing my sine equation by my cos equation. So the r's cancel out. Sine alpha over cos alpha makes tan alpha, and 8 over 2 makes 4. So shift tan 4, 1.326. And to find r, we use Pythagoras. So I won't go through why it works. So the square root of 2 squared plus 8 squared is square root 2 squared plus 8 squared, 2 root 17. So that was the exact value of r. So we have 2 root 17 cos theta minus 1.326. The first three terms of an arithmetic sequence are cos x plus sin x, cos x plus 2 sin x. So we're adding a sin x on every time. Given that S9 represents the sum of the first 9 terms of this sequence. Okay, the first 9 terms, find the exact maximum value of S9. So the first 9 terms added together. So we're going to have cos x, we're going to have 9 cos x's, because there's just one cos x every time. And then for sin x, we're going to have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. 36 sin x's. So we've got 9 cos x's, 9 cos x plus 36 sin x's. And I guess that's a multiple of, yep, so it's just 4.5 times our original. So 4.5 times this one. So it's 4.5 times 2 root 17 cos theta minus 1.326. So we want to know the maximum. So the cos part can go between -1 and 1. So the maximum is where that's equal to 1. So it's 4.5 times 2 root 17, which is 9 root 17. Was it exact we wanted? Yep, 9 root 17. So I'll write max the maximum is where cos theta minus 1.326 equals 1, which leaves us with 4.5 times 2 root 17, which is 9 root 17. Deduce the smallest positive value of x at which this maximum value occurs. So we want to know the smallest value where cos theta minus 1.326 is equal to 1. So shift cos 1, that's at 0. So it's where theta minus 1.326 is equal to 0. So that is 1.326. And that should have been x instead of theta. Like so. The curve C has parametric equations. X equals t squared plus 6t minus 16, and y equals 6 ln t plus 3. Show that a Cartesian equation for C is y equals a ln x plus b, where a and b are integers to be found. So we need to eliminate the t from this. We can make them both t plus 3 by completing the square on our first one. So x equals t plus 3 squared minus 9 minus 16. So x equals t plus 3 squared minus 25. So let's make it t plus 3 equals, so plus 25, and then square root both sides. Power half. Now I can substitute t plus 3 into my y equation. So y equals 6 ln 6 log x plus 25 to the power of a half. So I need to get rid of that power, so I can just jump it down to the front. 6 halves make 3, so 3 log x plus 25. The curve C cuts the y-axis at P, so crosses y when x equals 0. So that is 3 log 25. Show the equation of the tangent. So we need to find the gradient, dy dx. To C at P, so the tangent can be written in this form. So find the tangent at this point, 0, 3 log 25. So dy dx. So when we have our natural log, when we integrate it, it goes to 1. Differentiate it, sorry. When we differentiate it, it goes to 1 over. So it's 3 over x plus 25. And we're times by the bracket differentiated, which is 1. So that is our gradient. And when x equals 0, dy dx is 3/25. So we've got all the information we need now. So we just need to write the equation. So let's do y minus y1 equals m times x minus x1, which is just x. So ax plus by equals c log 5. Ax plus by equals c log 5. So times by 25. 25y minus 75 log 25 equals 3x. We want it to be log 5, so I can change my 25 into 5 squared. And then bring the 2 to the front. So 25y minus 150 log 5 equals 3x. How did I want it? I want the x and the y on one side and the log on the other. So it's, well, negative 3x plus 25y equals 150 log 5. question 10, we've got f of x, 3kx minus 18 over x plus 4 times x minus 2, where k is a positive constant. Express f of x in partial fractions in terms of k. So we're going to split it up into two separate fractions. 3kx minus 18 over x plus 4 times x minus 2 is going to be something over x plus 4 plus something over x minus 2. So if I times through by this denominator, I'll get 3kx minus 18 equals a times x minus 2 plus b times x plus 4. And then I'm just going to eliminate. So if I let x equal 2, I'll get 6k minus 18. My a is going to be gone. 2 minus 2 is 0, so 0 a's. And I've got 2 plus 4, so 6 b's. So divide through by 6. So b is k minus 3. And then let x equal negative 4. So we'll have negative 12k minus 18 equal to minus 6a. Divide through by minus 6. So we'll have 2k plus 3. So f of x is 2k plus 3 over x plus 4 plus k minus 3 over x minus 2. Hence, find the exact value of k for which, so the integral between 1 and negative 3 of f of x is equal to 21. So the integral between 1 and negative 3 of our function is equal to 21. So we'll integrate, substitute in 1, substitute in 3, negative 3, and take them away and make it equal to 21. So when we're integrating our fractions, they go to natural logs. So it's going to be 2k plus 3, which is just a number, log x plus 4 plus k minus 3 log x minus 2 between 1 and negative 3 equals 21. So let's just substitute in 1 and 3. So we've got 2k plus 3 times log 5 plus k minus 3 log 1 minus 2, so negative 1, log 1 minus 2k plus 3 log 1. So log 1 is 0. So they're going to disappear. Plus k minus 3 log 5. So the log 1s are going to go. So we've got 2k plus 3 log 5 minus k minus 3 log 5 equals 21. Let's expand Yeah, let's expand. So 2k log 5 plus 3 log 5. I'll leave the minus there for now. So minus k log 5 minus 3 log 5 equals 21. And then I'll just get rid of that bracket. So minus k log 5 plus 3 log 5. So what do we have? We've got 2k minus k, so just 1k log 5. And I've got 3 log 5s and another 3 log 5s, so 6 log 5s equals 21. So k is going to be k log 5 is 21 minus 6 log 5. So k is 21 minus 6 log 5 over log 5. And what are we trying to do? Find the exact value of k. So we can leave it like that. A tank in the shape of a cuboid is being filled with water. The base of the tank measures 20 meters by 10 meters, and the height of the tank is 5 meters, as shown in figure 1. At time t minutes after water started flowing into the tank, the height of the water was h and the volume v. In a model of this situation, the sides have negligible thickness and the rate of change of v is inversely proportional to the square root of h. So the rate of change of v is dv dt, and it's inversely proportional. So that's equal to k over root h. Show that dh dt is lambda over root h, where lambda is a constant. So dh dt, so we've got v is going to be equal to 20 times 10 times h, which is 200 h. We've got dv dt, we want dh dt, so we could say that dh dt is equal to dv dt times dh dv, because the v's cancel out and you're left with dh dt. So let's work out dv dh. Let's copy all this down. So dv dh is 200. So v equals 200h. So dv dh is just 200. So dh dt is dv dt, which is k over root h, times not dv dh, dh dv, so that's 1 over 200. So dh dt is k over 200 root h, and k is a constant, 200 is a constant, so we can change that into lambda over square root h. Given that initially the height of water is 1.44, 8 minutes after water started flowing into the tank, the height was 3.24. Use the model to find an equation linking h with t, giving your answer in the form h to the power of 3 over 2 equals at plus b. So we've got initial, so when t equals 0, we've got 1.44. And after 8 minutes, we've got 3.24. So let's start with our dh dt equals lambda over root h. And then let's turn this into an equation using, it's a differential equation. So I have root h dh equals lambda dt. So it's h to the power of a half and lambda. So integrate both sides, add 1 to the power, divide by the new power. So 2/3 h to the power of 3 over 2 equals lambda t plus c. And we know that when t equals 0, h is 1.44. When t equals 0, h is 1.44. So c is 2/3 of 1.44 to the power of 3 over 2. Which is 144 over 125. So we have 2/3 h to the power of 3 over 2 equals lambda t plus 144 over 125. And then let's find that, use that second bit of information. T is 8, h is 3.24. So we have 2/3 of 3.24 to the power of 3 over 2 equals lambda times 8 plus 144 over 125. So 2/3 times 3.24 to the power of 3 over 2 is 486 over 125. So take away the 144 over 125, 342 over 125 is 8 lambda. So divide by 8, 171 over 500 is lambda. So let's put that all back into our equation. So we have 2/3 h to the power of 3 over 2 equals 171 over 500 t plus 144 over 125. We want to divide through by 2/3 though to get h to the power of 3 over 2 by itself. So divide by 2/3. So 0.513 t and divide by 2/3. .728. Hence find the time taken from when water started flowing into the tank for the tank to be completely full. So that is when h is 5. So when h is 5, what is t? When h is 5, what is t? So 5 to the power of 3 over 2 equals 0.513 t plus 1.728. 5 to the power of 3 over 2. We want to take away 1.728. So 9.452 and so on. And divide by 0.513. So 18.4. And 18.4 minutes is our answer. Question 12. The number of subscribers to 2 different music streaming companies is being monitored. The number of subscribers, NA, in thousands to company A, so the number for A, is modeled by the equation the modulus of t minus 3 plus 4, where t is the time in years since monitoring began. The number of subscribers for B, NB, is 8 minus the modulus of 2t minus 6. So we've got a sketch of NA and NB over a 5-year period. Use the equations of the models to find part A, the initial difference between the number of subscribers to A and the number of subscribers to B. So initially, how many subscribers do they have? So when t equals 0, when t equals 0, NA is the modulus of negative 3 plus 4. So the modulus makes anything positive, so it'd be 3 plus 4, which is 7. And the number for B is 8 minus the modulus of negative 6, which is 8 minus 6, which is 2. So the difference, they're in thousands, so 7,000. Take away 2,000. The difference is 5,000. When t equals t, company A reduced its subscription prices and the number of subscribers increased. So just a value for t. So the number of subscribers of A is the modulus of t minus 3 plus 4. So it's going to have a minimum when the modulus is equal to 0. So the minimum is when t equals 3. So t is going to equal 3 because the point where it reduced its prices is going to be when it started gaining subscribers. So this is the lowest point, the lowest number of subscribers. Lowest number of subscribers. And part C, find the range of values of t for which where company A had more subscribers than company B. Give your answer in set notation. So where are these points where they are equal? Let's find the points where they're equal. So when the modulus of t minus 3 plus 4 is equal to 8 minus the modulus of 2t minus 6. So what are the values of t that make these equal? We could use the graphs here because we can see where they intersect. So when B has a positive gradient and A has a negative gradient, they intersect. And when A has a positive gradient and B has a negative gradient, they intersect. So if I could work this out twice, once for the positive gradient for A, once for the positive gradient for B. So we're going to have t minus 3 plus 4 equals 8 minus 2t minus 6. So we've got a positive gradient for A, a negative gradient for B. So that should be this point here. So let's find it. So t plus 1 equals 8 minus 2t plus 6. So 3t equals 14 minus 1, 13 thirds. And for this point here, A has got a negative gradient, so it's going to be negative t minus 3 plus 4. And B's got a positive gradient, so 8 plus 2t minus 6. So minus, but plus. So that's negative t plus 3 plus 4 equals 8 plus 2t minus 6. So negative t plus 7 equals 2 plus 2t. So that's 5 equals 3t. So 5 thirds. T equals 5. T equals 5 thirds. So where is A greater than B? It's where it's less than 5 thirds and bigger than 13 thirds. So set notation. So T is less than 5 thirds, and it's the union of when T is less than 5 thirds and when T is greater than 13 thirds. So that's our set notation. State a limitation of the model used for company B. So the limitation is, if we keep going, B is going to end up with a negative number of subscribers. So B will have a negative number of subscribers, which is not possible. Question 13. Find the first 3 terms in ascending powers of x of the binomial expansion of 3 plus x to the power of negative 2, writing each term in its simplest form. So the binomial expansion is going to be 1. Well, we need it to be a 1 at the front before we can do it. So let's have 3 to the power of negative 2 times 1 plus x over 3 to the power of negative 2. So now we've got a 1 at the front. So now we can use our binomial expansion, which is going to be 1 plus nx plus n times n minus 1 over 2 x squared. So we're just going to be substituting in. Our x is x over 3 and our n is negative 2. 3 to the power of negative 2 is the same as 1/9. So I put 1/9 times 1 plus nx, which is minus 2 times x over 3, plus n minus 2 times n minus 1 minus 3 over 2 times our x squared. So we're just going to need to simplify now. So we've got 1/9 times 1 minus 2/3 x. And then for this part, we've got -2 times -3 over 2 times 1/3 squared. So that's 1/3. So plus 1/3 x squared. Times through by the 9th, so 1/9 minus 2 over 27 x plus 1 over 27 x squared. That was the first 3 terms, which is what we wanted. Using the answer to part A and using algebraic integration, estimate the value of. So it's an estimate because we're using the expansion. Between the integral between 0.2 and 0.4 of, so our expansion times 6x. So 6x times 3 plus x to the power of -2. So it's 6x times our last answer. And it's integrate between 0.2 and 0.4. We can't use the calculator. We need to use algebraic integration. So estimate the value of that and then find the part C. So it's 6x, the integral between 0.2 and 0.4 of 6x times our expansion so let's expand it first, then integrate, and then substitute in. So the integral between 0.4 and 0.2 of 6 times a 9th, so 6/9 is 2/3, so 2/3 x minus 12/27 or 4/9 x squared, and 6/27 is 2/9 plus 2/9 x cubed. So now let's integrate, add 1 to the power, divide by the new power. So x squared, so 1/3 x squared minus x cubed, 4 over 27 x cubed, x to the power of 4. So 2 over 36 is 1/18 x to the power of 4. And then between 0.4 and 0.2. So we'll substitute in 0.4, substitute in 0.2, and take them away. And let's see what we get. So 1/3 times 0.4 squared minus 4/27, 0.4 cubed plus 1/18, 0.4 to the power of 4. Close that first bracket, take away, open the second big bracket. 1/3 times 0.2 squared minus 4/27 times 0.2 cubed plus 1/18 times 0.2 to the power of 4 and close the big bracket. I've got 223 over 6,750, 0.0330. 0.0330 to three significant figures. To four significant figures even. So 0.03304. And part C, find using algebraic integration the exact value of. So we're actually going to integrate this time. Give your answer in the form A lnb plus C, where A, B and C are constants to be found. So let's use a U substitution. So we'll have U equals 3 plus x. So we've got the integral of 6x over 3 plus x squared with respect to x. And we'll try a U substitution where U is 3 plus x. So if U is 3 plus x, we have dx du. So we'll have the integral of 6x over u squared. Du dx is going to be 1. So dx du is also 1. And if x is 0.4, u is 3.4, x is 0.2, u will be 3.2, and 6x is 6 lots of u minus 3. So that should be we should be able to integrate that now. So 6u minus 18 over u squared. So we have 6 over u minus 18u to the power of negative 2. So 6 over u will be 6 log u. 18u to the power of negative 2. Add 1 to the power, so it becomes negative 1. Divide by the new power, so dividing by negative 1 is going to make it positive. So between 3.4 and 3.2, so 6 log 3.4 plus 18 over 3.4 minus 6 log 3.2 plus 18 over 3.2. We want it in a certain form. A log b, where a, b and c are constants. A log b plus c. So we have 6 log 3.4 minus 6 log 3.2 plus 18 over 3.4 minus 18 over 3.2. So we've got 6 log 3.4 minus log 3.2, 18 over 3.4 minus 18 over 3.2 is minus 45 over 136. And then log 3.4 minus log 3.2. We can change the minus into a divide, which is 17/16. So we've got 6 log 17/16 minus 45 over 136. And just out of interest, 6 log 17/16 minus 45 over 136 is 0.0328 and so on. How close was that to our answer to part 0.03304? So it was in the same region. And that is all we have to do. Question 14. Show that the equation 2 tan theta times 8 cos theta plus 23 sine squared theta equals 8 sine 2 theta times 1 plus tan squared theta can be written as sine 2 theta times a cos squared theta plus b cos theta plus c equals 0, where a, b and c are constants to be found. So we are going to use trigonometric identities, and we've got tan theta is sine theta over cos theta. Cos squared theta plus sine squared theta equals 1. And rearranging this, dividing through by cos squared theta gives us 1 plus tan squared theta equals sec squared theta. So we can change 1 plus tan squared theta into sec squared theta, and tan theta into sine theta over cos theta. Let's do that to start. So 2 sine theta over cos theta times 8 cos theta plus 23 sine squared theta equals 8 sine 2 theta times, so sec squared theta. And we can change sec squared theta into 1 over cos squared theta. So 2 sine theta over cos theta times 8 cos theta plus 23, and I think I'm going to change this into 1 minus cos squared theta while we're here, equals 8 sine 2 theta times 1 over cos squared theta. I'm going to multiply both sides by cos squared theta. So I have 2 cos squared theta sine theta over cos theta, which is just 2 sine theta cos theta times 8 cos theta plus 23 minus 23 cos squared theta equals 8 sine 2 theta. And 2 sine theta cos theta is also sine 2 theta. What I'm not going to do is divide through by it, because I've almost got what we wanted. But if I divide through by sine 2 theta, I'll lose it. So what I want to do is take 1 away from, make it equal to 0, and then factorize out the sine 2 theta. So sine 2 theta times 8 cos theta plus 23 minus 23 cos squared theta minus 8 sine 2 theta equals 0. So I've made it equal to 0. And then I'm going to factorize out sine 2 theta. So sine 2 theta times 8 cos theta plus 23 minus 23 cos squared theta minus 8 equals 0. So I think we've got what we want now. So sine 2 theta times, I'm going to keep the positive at the front, so 8 cos theta plus 15 minus 23 cos squared theta equals 0. And part B, hence solve for 360 to 540 our equation. So solve this. So either sine 2 theta equals 0 or 8 cos theta plus 15 minus 23 cos squared theta equals 0. And we'll use the calculator to solve the quadratic. So negative 23x squared, 8x's and 15. So we've got 1 or negative 15 over 23. So we're looking for all the solutions between 360 and 540, but not 450. So we'll start with the sine 2 theta. I'll store this as A. So shift sine 0 is 0. So 2 theta equals 0. To find the next answer with sine, are we in degrees or radians? We're in degrees. Let's make sure the calculator is in degrees. So it doesn't make a difference for sine 0, it's still going to be 0. To find the next answer for sine, it's 180 take away the first one. And then they are going to repeat every 360 degrees. So it's going to be 360, 540, 720, 900, and so on. So we want between 360 and 540. Are we including 540? We are. So theta can be. So which of these are going to be between 360 and 540? So we're going to get 360, 450, but we can't have it. So we're going to have 360 and 540. How about for cos theta equals 1? Shift cos 1 is 0. The next answer will be 360. And then these repeat every 360. So 720. And 1080 again. So we've already got these answers. 360. And the negative 15 over 23. So shift cos A. 130.7. $360 minus the first answer, 229.3. These repeat every 360 as well. So I've got 589.3. That's too high. But I want shift cos alpha. Shift cos alpha, that first answer, plus 360, 490.7. So I have 3 answers in the range we want. So theta can be 360, 490.7, or 540 degrees. Question 15. A student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sine x minus cos x is greater than or equal to 1. The student starts the proof with, assume that sine x minus cos x is less than 1, where x is an obtuse angle. So we've got sine x minus cos x squared is less than 1. That's the first step. The start of the student's proof is reprinted below. Complete the proof. So we just need to carry on. So we're going to expand the brackets. So sine x minus cos x times sine x minus cos x. So that would be sine squared x minus sine x cos x minus another sine x cos x plus cos squared x is less than 1. So we have sine squared x minus 2 sine x cos x plus cos squared x is less than 1. And we've got sine squared x plus cos squared x, which we can change into 1. So we've got 1 minus 2 sine x cos x is less than 1. Take 1 away from both sides, so minus 2 sine x cos x is less than 0. And so the angle is obtuse. So when obtuse, for any obtuse angle, so an angle between 90 and 180, so in this quadrant over here, sine is always positive and cos is negative. So sine x is positive and cos x is negative. So here we're going to have a negative 2 times a positive times a negative. So a negative times a positive times a negative will always be positive. So there is a contradiction. It's bigger than 0. Therefore, there's a contradiction. Therefore, we can say sine x minus cos x is greater than or equal to 1. Sine x minus cos x is greater than or equal to 1.